Alright, we're going to do today lesson 2.5, addition patterns. So we're looking at, is it always true? Minna states that the total will always be odd if she continues to add 4 blocks to the set. So 3, and we add 4, it's an odd. If we add 4 more, it's an odd. So is it true if she adds 4 blocks every time to the set that it's going to always be odd? If you said yes, you are correct, because you're always going to have that 1 block when you add 4, because you're adding an even number. So last year in 2nd grade, we talked about odd and even numbers. Minna notices that when she adds an even number and an odd number, the sum is odd. How can she determine if the sum of an even number and an odd number is always odd? When you add even numbers and odd numbers, there are patterns in the sum. So, if we look at this, when you add 2 even numbers, the sum is even. So, see how the 6 is an even number, and the 0, it's going to be an even number as well, because we can divide it in 50 to 50. So when you add those two, it's going to be an even number, because we look at the 1's place value. 2 plus 4 is 6, so therefore it's going to be an even number. 8 plus 0 is 8, and it's going to be an even number, because you can group them in groups of 2. When you add 2 odd numbers, the sum is even. Well, we're going to have 1 extra here because it's an odd number, and 1 extra here because it's an odd number. So therefore, they're going to make a pair together, and it's going to be an even number. So an odd number and an odd number is going to make an even number. An odd number and an odd number is going to make an even number. When you add an even and an odd number, the sum is odd. Well, that makes sense, because everybody here's got their buddies. They're already in pairs of 2. But this one has 1 person left out, so therefore there's going to be 1 person left out when you do the addition problem. Same thing goes here. This one has all of these pairs, but this one's got an odd. So therefore, there's going to be an odd on your answer. This one is an odd number. This one's an even number. So therefore, it's going to make an odd number. You can use addition patterns to help you determine the sum to check your work on 3-digit numbers. So, when we talk about having math sense, Nisha writes 135 plus 232 equals 67. Boy, I already see an issue there. I hope you all see it too. She says her sum is correct because an odd number added to an even number equals the odd sum. Do you agree with her reasoning and explain? Well, I do agree an odd number added to an even number equals an odd sum, but I do not agree with her answer. Do you see why? Well, you're adding, and you got 100, and you got 200, so how many hundreds should you have? So right off the bat, her answer is incorrect. Now, if she had had a 3 there, it would have been correct, wouldn't it have? So you would have to explain that you agree that an odd and even number does equal an odd number. However, her answer in her equation is incorrect because of her hundreds place. Let's go over here and look at this. What makes the equation true? Write even or odd, then write two equations with three-digit numbers to support your answer. So, if this is an even and this is an even, then we know we're going to have an even. Now remember, 3 digits. So I have to have 3 digits. So I can have 124 plus 232 equals, now my ones place is going to be 6, my tens place is going to be 5, and my hundreds place is going to be 3. Some of you might say, well, Miss Haycraft, 5 is not an even number, but it's not 5 because it's a 10. So 50 is an even number because we can split it into 25 and 25. So they each have a buddy. So that is our proof for that one. Now if I have an odd and I have an even, therefore I'm going to have an odd at the end. Because if I have 127, which is an odd number, because 7 doesn't have buddies, and an even number, let's add 122, then I'm going to have 249, and 9 doesn't have buddies. Remember, when we're thinking about buddies, the reason that we only look at the ones place is because a 10 has buddies. If we had a 110, we would have, see, this is a 10, so each one of them have a buddy. So for every 10, we have buddies, and it's going to be an even number. So, now, if we have an odd plus a blank, it wants an even. So if we have an odd plus, he's got one left over, so we need another odd to make an even. Now remember, we have to have 3-digit numbers. So it's going to be something like 341 plus another odd, 3, 2, 3 equals 6, 6, 4. And see, it equals an even. Now, we've got an even plus an odd. Well, we're going to have an odd duck because that odd one doesn't have a buddy. So our even could be 494 plus 401. Because one's odd, 4's not. So it should equal an odd. We've got 895, and 5 is our odd number, so we are correct. Alright, so we have an even plus a blank. Oh, well, if we put an odd there, we won't get an even. So it has to be even plus an even. So we can have, let's see, let's have 5, 2, and it's an even 2, plus another even. Let's go 3, 7, 4, and it's going to be 8, 9, 6. So we're even and we're even. We're even and we're even. We're even and we're even. And remember, the reason we only look at the ones place is because we know a 10 is an even. We know he's even. So we don't have to focus on what's in front because we know 10s are evens. So we're only looking at the ones. Uh-oh, we have an odd and an odd. So maybe this one's a little confusing. And instead of 3-digit numbers to begin with, we're going to say, well, we're going to put odds. If I put a 1 plus a 3, oh, it's going to be a 4. So I know it's going to be an even. And then we can erase our thinking on making math sense. And we can put odd numbers. So let's have an odd number of 711 plus 223. And then we can have it equal 9 hundreds, 3 tens, and 4 ones. So we're even. So it works out. Now, moving down here. What is the sum? Use patterns to justify your answer. So this is going back to what we were taught in 2nd grade. Okay? So, use patterns. What is the sum? So we're going to have to add these together. Well, we know 6 plus 3, it's going to be a 9, and that's going to be odd. So my number should be odd here. So if I add my ones, how do I want to do this? So we've got this wonderful place value chart here. Ones, tens, and hundreds. And I have 486, and I have 123. And if I add these two together, 6 plus 3 is 9. 8 plus 2, that's a 10. I can only have one digit in my 10, so that means it's got to go over to my hundreds. 1 plus 4 is 5, plus 1 more is 6, so my answer would be 609. And is that odd? Yes, it is, so we are correct. Looking at this, we've got a 4 and a 2, so that should be an even, because that equals 6. Draw my place value chart. We've got ones, tens, and hundreds. We've got 272 for 272. And we've got 154. Draw my line and put a plus. I have 6 ones. Look here. I have 12. So that means my 2 goes here. I have 2 tens left, but I have to bundle it up and move it to the hundreds. And then I have 4 there. So I have 426. Now this can be said on regrouping because we have too many tens. And remember, when we have 10 tens, that equals 100. Now we get to the wonderful word problems, something Miss Haycraft loves. Why is the sum of a number with a 3 in the ones place and a number with a 4 in the ones place always an odd sum? So let's think about this again. Why is the sum, so this is when we add, because that's what sum means, of a number with a 3 in the ones place, so if I have a 3 in the ones place, and a number with a 4 in the ones place, so if I have 4 plus 3, always going to be an odd sum. Well, if I add 4 plus 3, I'm going to get 7. And that means, if I want to draw over here to explain, if I have 7, these two have buddies, these two have buddies, this two has a buddy, but you're always going to have one that's out. So therefore, that makes that odd. How can you explain why the digits in the ones place of the add-ins, remember add-ins is just the number in an addition problem, determine if the sum will be even or odd? Okay, so let's reread this. How can you explain why the digits in the ones place of the add-ins determine the sum? Oh, Miss Haycraft may have told you this answer a little bit quicker. So, for example, if we have 24 plus 21 equals, we know that it's going to be, because it's an even plus an odd, it's going to be an odd, because it's going to be 45. And it wants to know, why does the ones place determine? Why does that ones place determine if it's going to be even or odd? Well, remember what we talked about on the page previous? These are tens. So if I have a 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a 10 always has a buddy. So it doesn't matter if it's a 10 or if it's a 20. Doesn't matter because there's 20. Or if it's 30, 40, 50, if we keep going up. They're always going to have buddies. So the tens place is always going to have a buddy. Therefore, the ones that's only going to be left out is the ones place. So the ones place can be left out. And the same thing goes for thousands and millions, because you just keep getting larger, that our number system is a base 10. So it's always going to go back to that tens. A baking sheet can hold an odd or even number of pastries. If Shafran wants an even number of pastries, how can she arrange the pastries on 2 sheets? Well, a baking sheet can hold an even or an odd number of pastries. If Shafran wants an even number, how can she arrange it on 2 pastry sheets? Okay, Miss Haycraft's doorbell is ringing. So you have 2 pastry sheets. How are you going to arrange that?